Hey everyone in 10 Science. I'm making a video today. I'm going to go through the lab procedure that you're going to write a report for. And so I'll just explain what I'm going to be doing each step of the way, and you guys can record the data as I go through the steps, and I'll read out the measurements to you, and I'll just explain exactly what I'm doing all the way through. So this PDF you should have, you can print it if you like, or you can just follow along on your computer. But we're going to be doing two reactions today. First one, part A. On your lab instructions it says iron 3 nitrate and sodium hydroxide. I decided to change the iron 3 nitrate because it's a little boring. The chemical that I decided to use instead is cobalt 2 chloride, which you can see right there, hopefully. Cobalt 2 chloride, so it's CO, Cl2. And there's a little note here saying that iron 3 nitrate and sodium hydroxide are both corrosive. Well, cobalt 2 chloride is also corrosive and toxic and an irritant, so the same safety note would apply for the cobalt 2 chloride. So I've got my goggles on, and I'm gonna be careful not to get any on my hands, or I'll rinse them off right away. So first reaction, here is our cobalt 2 chloride solution. It's a nice pink color there. And basically what I did was I took some of the cobalt 2 chloride solid and I scooped it into the beaker, added some water and stirred it up. So now it's fully dissolved cobalt 2 chloride solution, so aqueous. We also have some sodium hydroxide solution, NaOH aqueous, that we're going to react with the cobalt 2 chloride. So I'm just going to follow the steps here. Part A, I've got my Erlenmeyer flask with the stopper, and I've got the test tube that I'm going to put inside. So I know that my stopper makes a good seal on the flask on top. I've already tested that. So on to step 3, measure 5 milliliters of sodium hydroxide solution in the 10 milliliter graduated cylinder. So I'll do that right now. This can be rough. It doesn't have to be exactly 5 because we're going to be finding the mass, and that's the important thing. So I'm not going to spend time making it perfect, but it'll be somewhere around 5. So there's my roughly 5, and I will just pour it straight into the Erlenmeyer flask here. All right, next step, over to step 4. Your teacher will assign each lab group a different volume of the iron 3 nitrate, which is actually the cobalt 2 chloride solution. Well, we don't have different lab groups. There's only one lab group today, and that's me. So I am going to set this test tube in a beaker just to hold it safely. And I'm going to pour some cobalt 2 chloride into the test tube. And it really doesn't matter how much I use. So, I don't know, let's go with, how many is that? That's about 2 fingers right there. Okay, so make a note of the color. I'll put a white background behind it there. You can see the color. And what it wants me to do now is tilt the flask and carefully slide the test tube into it. Okay, done. So that's what we've got there. We've got the sodium hydroxide in the bottom and the cobalt 2 chloride in the test tube. So they are not touching each other right now. Next, seal the flask with the stopper. Okay, got that on there nice and tight. And I'm going to turn on my balance here. And you probably can't read the numbers on it, but I'm going to make sure it's leveled out at 0 to start with, and it is. I'll just push 0 again. So step 7, measure and record the total mass of the flask and its contents. So this is everything here before the reaction happens. So I'm just going to pop it down on the scale. Oh, it's giving me an error. Too heavy. The scale only goes up to 200 grams, so the total is actually over 200 grams. So that's no good. I'm gonna have to use the smaller Erlenmeyer flask, which I have as a backup here. So I'm gonna do a little bit of a rewind. I'm going to remove the cobalt 2 chloride, and all I really need to do is transfer the sodium hydroxide solution into this smaller flask. I just want to make sure that's well below 200. Yeah, it's only about 100. So I've lost some sodium hydroxide in that other flask. And again, this is rough. The exact volume doesn't matter. So I'm just going to top it off here with a little more sodium hydroxide. Great. Now I need to transfer this to a smaller test tube as well, because the big one isn't going to fit. So I will just transfer the cobalt 2 chloride into a smaller test tube, and these two we can put away. All right, back into the flask, and I will seal it up. Perfect. I'm gonna zero the scale one more time to be sure. Okay, so now we've got everything we had, but just in smaller containers. And let's find out the mass of this here. I'll try and show you on camera here, but it's 150 grams. We've got the fan blowing from the ceiling, so it's kind of changing it, but let's say 150.79. All right. So that can be recorded in your data table. This is reaction 1. So you will be making a prediction about the mass change. Will the mass decrease? Will it not change, or will it increase? And then the initial mass of the reactants plus container is what you're going to write this value for, 150.79 grams. So that's the second row for reaction 1. We will find out the final mass of the products. We'll move on to step 8, slowly tip the flask to allow the two solutions to mix. So again, make note of the color here of the cobalt 2 chloride. And now I'm going to tip it and allow these solutions to mix. That was pretty quick. Very cool color change there. As you can see, we've got the sodium hydroxide mixed with the cobalt 2 chloride, and I'll just swish it around a little bit. My stopper is still sealed on top. It's this nice deep bluish purple color. So we obviously had a chemical reaction because there's a color change. I'm going to zero this and find our next piece of data. This is the final mass of products plus container in grams. And bring you over and we'll check out the reading. 150 point. It's jumping around again, but let's call it 150.77. Pretty much the exact same value as the initial mass was. We do have the fan blowing right above us here, so it is causing a little bit of value changing on the balance by a few hundredths of a gram. So that's reaction 1. Step 9, we've just measured the total mass of flask and contents. Return the flask and all of its contents to your teacher. That's me. Thank you. All right, part A is done. And we'll move on to reaction 2, which is part B, an antacid tablet in water. So what I need to do first, grab a beaker, 50 mils of tap water to the plastic cup. Well, this is gonna be our plastic cup today. It's a glass beaker. Tap water, I could use tap water, but the actual water taps are shut off and I'm a little too lazy to go find the key and turn it on. So I'm just gonna use this jug of water and roughly 50 mils. It does not have to be exact. All we care about is the total mass before and after, right? So I've got, I went a little over. I got about 55 mils of water, but that's fine. I'm just gonna add that to the beaker. Nice. Now, what's the next step? Take an antacid tablet out of its package. I already did that. That's our Alka-Seltzer right there, full tablet. Place the tablet and the cup of water on the scale. So I'm not mixing them yet because that would start the reaction. So zero the scale again. Now I've got my beaker of water and the tablet, getting the mass of that in total. So back to our data table. This is the second row for reaction 2. The initial mass of reactants plus container in grams. Let's check it out. We've got a mass of about 120.34. 120.34. Okay. Next step, add the tablet to the water. Well, that sounds very difficult, but I'm going to try my best to do that. And let's see, I might tilt you guys down a bit so you can see this better. You don't need to see me, you need to see the reaction. So there it is. And I'm just going to add the tablet to the water, and you can make note of what's going on when I do that. Lost a few drops there. Come on in closer, check it out. You might be able to hear it, I don't know. Reaction slowing down a little bit now. Not so much noise, not so much fizzing. And we don't have much tablet left in there. Make sure we get all of that tablet powder reacted. That is pretty much the end of the reaction. We just got some bubbles there that are stuck to the inside of the beaker. Try to get rid of most of them. So we are basically done. I'll just set that down here. Slide everybody back. So what's the next step? When the visible reaction has stopped, yes, measure and record the total mass of the cup and its contents. All right, gonna zero the scale again. Let's find the mass here. what do we got this time? 119 point, let it balance out, 119, let's call it 0.80, 119.80. That is our final mass of products plus container. So from that, you can work out the change in mass, final minus initial, and write down if we had any observed change. So that's basically our data table. We have 5 pieces of data for reaction 1 and for reaction 2. And then the final row there where it says observed class results, decrease, no change, or increase. Well, we don't have a bunch of different groups doing this same reaction, so we cannot compare. So just leave that row of your data table out. You only have to do the first 5 rows because we're only doing one version of this reaction because we're online and that's the way it goes. Okay, so we've done both reactions, and now for the analyze and evaluate section of your lab report, really important that you don't have to answer all of these. So just put a big X through B, don't answer B. Don't answer C, don't answer D, don't answer F, because that is all asking about class data and averages. So obviously we can't compare many different groups together. So the only letters that you should be answering in your lab report are A, E, G, H, I, and J. And one more note for G, it says, would the class results for part B differ if the reaction were carried out in a sealed container? Well, just don't worry about the word class. So that should read, would the results for part B differ? Because we only did it once. But the same question applies. Okay, I will have some more written information in the announcement for today about how you will write up your lab report, but it's quite a small report. We'll give you some info about the formatting and how to submit that. But that's it. That's it for the lab video. And I hope you enjoyed. I hope it was extremely entertaining for you, especially the color change of the cobalt 2 chloride with the sodium hydroxide. And hey, as an extra challenge, can you predict the products of that reaction? Cobalt 2 chloride and sodium hydroxide. What type of reaction is it from the 5 types that you learned about yesterday? And what products would be made based on that type of reaction? Let me know. Send me a message if you've got it figured out. All right, bye for now.